In today's lesson, we'll be learning about rate of change and initial value with a focus on graphs. As discussed earlier, a linear relation is really just a pattern, and this can be represented with an equation, y equals rate of change multiplied by x plus initial value. As you can see below, we have a graph. This is the x-axis, while that is the y-axis. The x-axis represents time, and the y-axis represents distance. A graph represents a pattern. We've seen these patterns represented as diagrams and table of values. Over here, at 0 seconds, you have a distance of 20 meters. At 1 second, you have a distance of 16 meters. At 2 seconds, you have a distance of 12 meters. At 3 seconds, you have a distance of 8 meters. At 4 seconds, you have a distance of 4 meters. And at 5 seconds, you have a distance of 0 meters. That brings us to an important question. What is the rate of change and what is the initial value? Take a close look in the top left corner. For every 1 second, your distance decreases by 4 meters, so that would be -4. Let's take another look. For every 1 second here, your distance again decreases by 4 meters, which is -4. You'll start to see a pattern. Therefore, the rate of change is -4, since your distance decreases by 4 meters for every 1 second that passes. Meanwhile, your initial value is your initial distance at 0 seconds. Therefore, that would be 20 meters. We can now represent this pattern with an equation. Instead of writing rate of change, we can write -4, since your distance decreases by 4 meters for every 1 second that passes. Meanwhile, your initial value is going to be 20, since that was your initial distance at 0 seconds. Therefore, this situation can be represented with the equation y equals -4x plus 20, where y represents your distance in meters and x represents your time in seconds.